Welcome, everyone, to the NUSAI Health Community. This initiative, brought to you by the Alice Lee Center for Nursing Studies, ALCANS, at the Yon Luoline School of Medicine, National University of Singapore, NUS, is part of the NUSAI Community of Practice, NUSAI-CA. Our primary aim is to educate healthcare professionals on the application of artificial intelligence, AI, in healthcare. This project is funded by the NUS Center for Teaching, Learning and Technology, CTLT, Teaching Enhancement Grants, TEG, FY 2023/2024. Within our learning community, we offer foundational AI knowledge and skills tailored specifically for healthcare professionals. We also promote collaboration and share AI-integrated teaching plans for healthcare education among local and international participants. Allow me to introduce the dedicated members of the NUSAI Health Community who contribute their expertise and enthusiasm towards leveraging AI for the betterment of healthcare. We also extend our gratitude to NUS Center for Teaching, Learning and Technology, CTLT, for their invaluable contributions towards funding and publicity, which have been instrumental in making our community thrive. But that's not all. Brace yourselves for our monthly webinars featuring expert speakers delving into AI and its myriad applications in healthcare industry and education. Additionally, our platform serves as a hub for learning resources and event updates, ensuring you stay updated of all the latest developments. And if that's not enticing enough, our YouTube channel hosts a wealth of training courses focused on AI in the healthcare industry and education. Don't miss out on the opportunity to be part of this dynamic community. Subscribe to our channel at NUSA Health Community and visit our website to stay tuned for exciting updates on our upcoming events.
Hello. Good morning from Singapore. Good morning, researchers, educators, and all participants. Thank you for joining us today for our webinar series organized by NUSAI Health Community, National University of Singapore. My name is Piani Yobash, and I am happy to be your host today. Please be informed that this webinar will be recorded and we will upload all the webinar video onto our social platforms, including website, Instagrams, and YouTube. It is my absolute pleasure to introduce our esteemed speaker. He is an AI researcher at AI Research Center, University of Quebec, Montreal, Canada. He received PhD degree in computer engineering from University of Montreal, Canada. He has extensive experiences in user modeling, data mining, and artificial intelligence for education. Today, he will deliver a webinar entitled AI-Assisted Assessment. Please join me in welcoming Dr. Simon. Dr. Simon, please take it away, take it from here.
Yeah, thank you for having me today. And then, so today I'm going to present about the AI assistant assessment. Yeah, my name is Simon. Okay, let me share my screen. Can you see my screen?
Perfect.
Yeah. Today, I'm going to talk about the AI assistant assessment. Before taking into the main topics, I would like to firstly clarify about some things. But AI is not just ChatGPT, because I want to clarify this point, because if we talk about AI, a lot of people thinking it associated with the ChatGPT because of its impressive performance, human-like responses to the user. But the ChatGPT stand for a generative pre-trained transformer. It belongs to the conversational AI, and it is a type of large language models. So we have a lot of another sub-branch like machine learning, deep learning, natural language processing. We still have the computer visions, reinforcement learning. Those are not described in this graph yet, but those are still exist. And so where we have a lot of sub branches, but the GPT is just only belongs to the LLM, and LLM just the sub branch of the AI. So this is just for the clarifications. So today we use AI in education. Why do we use AI in education? We want to improve the student engagement with the learning platforms, and then we want to improve the learning outcomes of the student. So how do we improve these engagement and learning outcomes? We want to give the personalized learning experience to the students. So that is similar to the one-to-one teachings in the traditional setting, like previously. Those one-to-one teachers is only available for the limited person. And now with the advances of the AIs, we want to assist we want to provide this kind of assistance to the everyone's to enhance the accessibilities and provide the all-inclusive education to the students around the world. So when we talk about the users of computers in AI, we can start with the Plato system. Plato system is we can recognize the very first computer adaptive assistant instruction system in the world. It was developed in University of Illinois in 1959. So in the Illinois Board of Education at the time, they have an ambitious mission like that, deploying the 40,000 student terminals in the school by 1974. This is, we can say, the start of the usage of computers in education and learning platform. So I would like to go through a bit about the major milestones of AI in education. So we can start with the first proposal of the item response theory. This is the very famous theory in education and testing. And we are still using this item response theory right now. And then we have the first development of Plato system. And then in 1970, we have the first computerized adaptive test appears by Education Testing Service in the United States. And 1980, we have use of a lot of expert system to develop the intelligent tutoring system like the Sophie and GI Dome to provide the adaptive instructions in electronic and magnetic diagnostic courses. So even though we use the intelligent word in the tutoring system, but at that time, the system are not that intelligent right now. So, and then we have the peers of the adaptive learning platform like ALEKS. And then in 2000, a lot of commercializations like the Carnegie Mellons and Carnegie Learnings and Newton's, those companies appears. And since 2010, we have a lot of usage of AIs or in application of big data in the educations. So since 2010, we are developing very fast in the field. So with the frequent users of the AI in education, there are also concerns related to the users of AI, something like data privacy. Even today research showed that even the data is anonymized. The researchers are able to manage to re-identify the persons who is most likely to be the person with that data. Let me give you an example with the movie rating, IMDb data, or the movie ratings. There is a data challenge. The researchers are managed to match the profile of the user and the postal code of that user. So this is a kind of scary, right? So a lot of educational institute, they collect a lot of data and they do not dare to share this data because of the privacy issues. And then we have the quality of the online education. So after the COVID, we have a lot of usage of the online platform to provide the online education. But how this online platform is compared to the traditional classroom, which one is more effective, is a kind of questions. And then assessment is like a lot of platform, they have a lot of learning material contents, and they are programming courses. and they are likely to give the high-stake testing at the end of the program or the course, but there are a lot of platforms they cannot give the formative assessment to monitor the progress of the student throughout the learning process during the course. So that's why we are here today to make which kind of explore assessment is able to use for this kind of online learning platform. And then we have the ethical concern about the ethical uses of AI and machine learning. Today's AI and algorithms are mostly data-driven. So if the data we use have there's ages or bias, we cannot, the output given by the AI system will also have the bias. So besides the models are more and more complex, the performance, those complex model has a higher performance, though a lot of people are willing to use these complex models, and then so it raised a concern about how we can track this outcome, the output of the AI system. If the model is quite complex, we cannot interpret what is happening inside the black box in the black box. So these are the rising issue of AI in education. So I would like to switch to the main topic, like the AI assistant learning system. So we use the AI assistant learning systems. When we talk about AI assistant learning system, it's not as a robot coming into the classroom and teach to every student like this. We would like to use this system to assist the teachers to provide the student insight of their understanding, and then and notifying them to when there's where the students need to further improvements. So these systems require, of course, AI algorithms. Those are based on the cognitive theory. So in the development of the adaptive learning system, what AI will take roles. So to take the AI will take a role to automate the tutoring process to some extent. So that's why we can improve the student learning experience. Let's say there is only one teacher in a classroom, and then if the teacher is occupied by someone else, the student need to wait. But therefore, some simple problems, examples, it will be assisted through by the use of AI that might improve the student learning experience, and then of course to increase the learning outcome by automate personalized learning part. The most important thing is to keep in the student in zone of proximal development. Proximal development is the intersection between what student already know and what student haven't known yet. So the materials in that zone of proximal development will help to construct the knowledge of the students throughout their learning process. So these are the fundamental building block for the building adaptive learning systems. What are those? Is domain models. So in where there we can do how to validate the correct and accurate domain model, and I will explain a bit more detail later. And then we need to have the student models that is required to provide the student knowledge assessment. And then we require the learning policy that we are gonna give the personalized learning part to individual students. So our goal is to provide to develop the adaptive learning system. So in OM, we use the AI assistant assessments. So when we talk about AI, that is kind of multidisciplinary, came from cross study like the learning science and cognitive modeling from the educational psychologies and the use of AI and machine learning technique from the computational science to provide AI and assistant assessment. This is one of my research directions, and then yes, there's a lot of journey to go. So I would like to start with the development of the. So far, is there any questions? Okay, so I would like to go to the development of the domain model. So In the basic psychometric modeling frameworks, it is really important to know about the domain models. What is domain model? Domain model is a kind of is a knowledge representation behind the problems. It is required to make the cognitive diagnosis. Let me give you an example with these problems. How to solve this problem correctly? We can generally say, okay, you are required to have the arithmetic knowledge to solve this problem correctly. But to have the more fine-grained representation of knowledge, we can say, okay, you are required to have the integer knowledge of integer additions, integer multiplications, integer decimal notation, decimal multiplication, decimal addition. So those represents, these are the knowledge to required to solve that problem correctly. So that's what we call domain models. So Q-metrics is one of the most important domain modeling technique. And it is the showing of the mapping of the test to the scale knowledge component. In here, row represent the item or test, whatever you call. That we have in the column, we have the scale or knowledge components. We have the 10 items and the 5 knowledge components. So the binary metric represent the requirement of that knowledge, and the 0 represent non-requirement of that knowledge. For example, in here, item 1, it required to solve the item 1 correctly, the students will require to have the knowledge number 1. To solve the item 2 correctly, students need to have the knowledge scale 1 to 4. So this is the representation of knowledge, and we call it Q-metrics. So these knowledge components are latent. We never observe in the real world. So these Q-metric is usually driven by the educational or domain experts. And there is no single theory or technique to define the structure or representation of the knowledge for our domain. So in here, let me give you a bit about an example about the basic psychometric modeling framework. In here, so as I previously explained, we have the Q-metrics. Those are usually driven by the domain experts. So we have the access to the response metric. What is the response metric? Response metric is the students' response to the questions. So in here, we have the 9 questions. That's the 4 students. Each student respond to a question. So by knowing that these 2 metrics, we can do the cognitive diagnosis. We can estimate what kind of scale student has. Let's for example, in here, we have the item 1 that requires scale 1 and scale 2. The student 1 cannot answer the item 1 correctly. He might be missing one of these scale, 1 or 2 of these scale. But the student 2 can answer it correctly. The students have at least have these 2 scale. So by analyzing all the student responses, we can estimate the profile metrics that we call cognitive diagnosis. So the mastery of the present of the knowledge or by the student is defined by the profile metrics. So that means Q metric is extremely important to make the cognitive diagnosis. And if we wrongly define the Q metrics, it will result about the false diagnosis. So during the past decade, a lot of researchers trying to have the data-driven Q-metric refinement techniques. I'm not going very detailed into these techniques, so because of the matter of time, but none of these methods give us a perfect refinement. So in 2016, I also make a contribution in that publication, like the use of the ensemble technique, the uses of the various Q-metrics refinement method to provide the final solutions that give us a better refinement than any single method. So this is how do we use the cognitive diagnosis with the Q metrics? So These are the usages of the Q-metrics. We have, as I previously explained, we use it in a cognitive diagnosis. We can also use in curriculum design because Q-metric is the mapping of the items to the knowledge. So the educational expert can identify which knowledge is required for which level of studies and which items will be used to construct the knowledge based on at a different level of study, right? So these are the two usages of the domain Q-metrics in domain models. So far, is this okay? Yeah. So after knowing about the Q-metrics, domain modeling, we would like to switch to the development of the student model. So that we usually do assessment. So when we talk about the assessment, we usually deal with the two types of data. One is the static, another one is dynamic data. When we talk about static data, it came from the standardized test. Everyone who have to answer the same questions during the exam. So the difference between the static and dynamics in the dynamic data, you can see the items received by the students is different, and that the number of problems they receive by the students will be different. It's why we use the different length of problems and the different problems in our testing. So at each time student make a response to the problems, their ability or their knowledge mastery will be re-estimated at each time, and then he will be given a problems that is appropriate to that current level of knowledge. So every time they make a response, their knowledge will be re-estimated, and the variance of their knowledge is not too much, and they converge. So this is the idea of the computer adaptive testing. So those data came from the computer adaptive test. So those two types of data also belong to the summative assessment. So when we do the high stake testing, so the finally the user will receive a score at the end of their test. So when we talk about the computer adaptive testing or standardized analysis of the standardized tests, we are dealing with the item response theory. Item response theory is the very famous models, statistical models, those they using until now by the educational testing service in the United States. And then it can be divided into the three versions, and like the 1-parameter models, 2-parameter models, and 3-parameter models. So in here, 1-parameter models, we also call the rush model. So in rush model, it only focuses on the identifiability. The student abilities and identifiability define whether the student correctly answer or not. So in the 2-parameter model, in the theta represent the student ability. In the 2-parameter models, we have the additional feature parameters that call the ident discriminations. And then the 3-parameter models, we have the another additional features and guess parameter. So I'm not going to get into these models as well because of it doesn't matter that. In here, I visualize a graph. This x-axis that represent the student ability, and the y-axis the probability of the correctness to the items. So in here, you can see this item 10 that is less difficult, and the student with the lower ability, even the student with the lower ability, they may answer the item 10 correctly. So this item is less difficult compared to the items in the right. So this is the basic idea of the item response theory. And then so in the item response theory, the student ability is static, and that it is not we assume that the student knowledge doesn't change during the exam. So these are the users of the IRT. We from the item perspective, we can select the items that is related that is tailored for the in the personalized testing, that's question tailored to the specific ability level of the individual students of the group of students. So we can also equate the test across the two age groups. So if we need to give the common items to the both of the two groups, and then we can by seeing that which items are easier for the which group and which items are harder for the which group. And then from the assembly perspective, we can estimate the student ability level, even the students skip their questions, they didn't answer the questions. And we can also analyze the average ability level associated that with the different responses. So we can also do the comparison across the group, something like in the large-scale testing program, like the Australian National Program, NAPLAN, and the international program like the PISA. In the plan, you can see that there is a different level of the student with a different level of band score, and then which students are in minimal level or national minimum standards, and who are above and who are below at a different level of study. So this is the main usages of the IRT. So far we are good. Yes,
Good.
right now from the high stake tasking to we are going to the section of formative assessments for the adaptive learning environment. So the difference between the static and high-stake tasking and adaptive formative assessment in adaptive learning is the human learning is involved. That's where the human learning is quite complex. It's based on the multiple dimension like practice, metacognitions, motivation, perseverance, effort, etc. But some of these dimensions are difficult to explore. So usually we use the cognitive modeling to where we study about the student ability to change or adapt that define the student learning ability throughout their learning process. So in the dynamic, in the adaptive learning environment, we only have the one type data, this or dynamic data. So those data usually came from the tutoring system practices. So in here, we can see the student came to the system at different time. The student make the response. Student will take a break sometimes, and then we take some may take longer, some take very short, and student may quit the system at any time. So we don't have the control over the students, unlike the testing, high-stake testing. And here we borrow the idea from the computerized adaptive testing. Every time student make a response, we are gonna estimate student ability or mastery level of knowledge, and then the new items will be assigned according to their ability. So this is the basis idea of formative assessment. So we use the student models to make the assessment. What we take is the student's history of student interaction responses, and then we estimate the student's ability or mastery data, and then we just decide, okay, if we set a criteria that is something like 0.95, if the theta is greater than 0.95, we can assume that the student has already mastered the knowledge that has already reached the mastery on that knowledge. The one thing what we need to know about is we can only observe the student performance, and we never observe this data. So that means we do not have the ground truth to validate. So how do we validate it? So but the assumption that the mastery of knowledge determines whether the student will make the correct response to the item associated with that knowledge. So we usually predict the next problem correctness that is associated with the knowledge state of the mastery. So in here, so we according to the data types, we can divide the student models into these two groups. So those in the first in the static data, we have the item response theory models. There's a family of item response theory model. And then we have the algorithms related to the diagnostic classification models. Those are what I have similar to what I have explained in the psychometric modeling framework. And then we also have the dynamic data. We also use the IRTs and adapted versions to deal with the dynamic data as well. We have the hidden Markov models, patternized models that are quite similar to item response theory because both models use the logistic regression models, but the further analysis model work on the scale level rather than item response theory work on the item level. So we also have the usage of the deep learning method in the student modeling. So these are the two different group based on the type of the data. So I would like to go to the Bayesian knowledge tracing. So with the development of the adaptive learning environments, so the IRT doesn't fit because IRT only provide the static knowledge state and it doesn't fit to the knowledge, the idea of knowledge state changing in the adaptive learning. The knowledge state of the student is changing over time. So the Colbert at the Carnegie Mellon University, they develop models that use the hidden Markov models to study about from the changing of the state from the not land to the land state. That's we call is Bayesian knowledge tracing. And it works on the 4 parameters. Those are aligned with the psychological theory. In here, we have the probability of landing, initial landing, and the probability of transition, probability of gas, probability of slip. Every time student make a response to a problems, so the algorithm, the system will go to update with, if the student make the correct response, this algorithm, the system will take this equation to update the knowledge state. And if student make the incorrect response, the algorithm will take this equation to make the update. And then we estimate the the knowledge state of the students by using this equation. So this is the basic idea of Bayesian knowledge tracing. So for the more visualizations that we visualize the example in here. The student who these are the items or problems that the student receive, and then those are the scales related to that problems. So these scale IDs that came from the Q metrics that I have previously explained. These are the responses, student responses to the problem. So in that sequence, we can see we have the student practice over the three scales, KID2, KID5, and KID9. Every time student make a response to the item related to a scale, so we are going to update the knowledge state of that particular scale. So every scale has their independent model. So if the estimated probability of mastery is less than 0.95, so it's gonna be keep giving the similar problems related to that scale. So this is the basic idea of how do we use adaptive knowledge tracing and adaptive learning environments. So since 2015, Pish and his colleague just introduced a deep knowledge tracing that's used of the recurring long short-term memory to represent the student knowledge state. You can see here's the in this every time student make a response, they just give what scale student practice and whether they get correct or not. By giving these two information, they can predict whether the student will get the correct answer in their next problem. So feature extraction, everything is scanned in the model. So we do not, by you can see the model is quite complex, and we cannot we have a lot of parameters, and we cannot interpret this parameter by our eyes. So, but that these deep knowledge tracing have the amazing performance at that time. So at that time, this deep knowledge tracing is the models that give us the is the most better accuracy than any other previous models. So according to the type of their structure of the student models, we can also divide into two groups. One is the highly structured models with the psychologically meaningful parameter like the IKT, IIT, PKT, and PFA. But the problems is they have the very low predictive accuracy. And another types that since 2015, a lot of researchers proposed a range of deep learning-based models to deal with the knowledge tracing task. And then they are they are fancy, more and more complex, but they have the higher predictive accuracy. So in here, I would like to explain the idea of how do we test our models, student models or machine learning model, whatever you call. So in here, we use the 80% of the to train the data, and then we tune the parameters to optimize models. And then we test with another 20% of the unseen new data. So how do we differentiate between the good and bad model? If we can, when we train the models, they can achieve let's say 90% of the accuracy. But when we predict the new unseen data, if we achieve the 80% of the accuracy, we can say, okay, this is a good model. In the second, for the bad model, if we can train the data, the models with the training data, we can achieve the 100% of accuracy. When we predict with the new data, we can only have the 20% of the accuracy. We say, okay, this is a kind of bad model. So in 2022, I have proposed an alternative method that is based on the Bayesian knowledge tracing, BKT, and then with the adaptation or the trigonometric line base, the model is quite simple, and then it provides a psychologically meaningful parameter. And then it also shows the competitive performance like compared to the deep neural network models with the low time consuming. So again, you see IIT is the adapted version of the IIT. It has every performance 0.768, and then PFA 0.70. The Bayesian knowledge tracing alone is the 0.638. Our model is adapted from the PKT, but we can achieve the 0.80. So these models in the green orange areas, those are deep neural network models. So our models also show the competitive performance like deep knowledge tracing models without requiring the high training time and computational resources. So we did the experiment over the data set like the 80K to the 2.5 million records. So if you're interested in, go to these publications and take a look. So in the knowledge tracing, I would like to introduce one of the important concepts called weak spinning. Weak spinning is a state or stacking in a state that cannot reach to the mastery. So to define a weak spinning phenomena status, we have to use the two thresholds. One is the mastery probability threshold that I have previously introduced. And then we have the attempt threshold. Let's say normally students achieve their mastery within 10 attempts. If the student cannot achieve the mastery within 10 attempts, we can say, okay, this student in the stage of weak spinning. So those are the students in the risk, and then we need to immediately inform to the teacher to make the interventions. So these are the challenges related to the knowledge tracing. Most of the interpretable models are work on the if it's sequential models work on the scale independently, but to trace the knowledge stages across the multiple scales is also challenging problem as well. Yeah. And then we also have the Boston line learning rates. So most of the model have the same learning rate for every student, but we should use the Boston line learning rate instead of the general learning rate. So besides, we need to consider like the having additional contextual factor like the hints and we use of the multimodalities for the emotion effects and how do we construct multimodal models, student models to provide the assessment. That is also very important. Is important challenge in the field as well. So as we already know, the deep learning models are quite complex. They are able to capture the complex pattern, but sometimes we need interpretability in the usage of the making an important decision. So we need to be careful usage of the deep learning approaches in the appropriate content. So finally, we have the student models is important and the fundamental building block of the adaptive learning systems, and that we are on the way to improve. So I would like to go to the future directions. So in here, these are the challenges faced by the adaptive learning system. AI assistant adaptive learning system. So in terms of transparency and explainability, scalabilities, and trace-offs. So CAT has a long history. It is usually given by the Education and Testing Service in the United States. Let's say GI CAT. So it is for the graduate record exam. And then even the ETS is an organization with a lot of psychometricians and then statisticians. They is the organizations aim for the giving the test. So even the CAT they may generate many incidents like in 2000s to GICAT have produced the unreliable scores, and the ETS has to request the student to retake the charge. And then in 2002, they're also in the CAT GMAT. They also produce unreliable scores. And so at that times, the models they use is not that complex. Right now, today's we have a lot of complex models. And then, so we need to be very cautious when we use the complex models in our assessments. So to provide the adaptive learning platforms, so of course infrastructure scalability is very important. We need to have the computer, at least to have the computer or tablet to provide the adaptive learning, to use the adaptive learning platforms. And then we have the use of the AI techniques for providing large-scale assessment based on the large data. So we might need the infrastructures to deal with the if we consider about the multimodality in our student models. So it will require the huge large computational scale computational resources to deal with this kind of modeling. So besides having these two computers and AI technique is not enough, so we need to develop the systems that require the pedagogical and technological requirements under the real world constraints. So in here, these are the challenges based on the trade-off, whether the student, we need to identify whether the students is overpriced or underpriced. Sometimes students is really enjoying the content, and but their learning outcomes is not improving. So this kind of problems, we need the trade-off between the engagement and the learning. Also, we need to focus on, and then so sometimes students a lot of hints are given, students get annoying based on the hints that they might receive. and then beside the interest of students and researchers, and then researchers are willing to improve the more fancy models and more complex models to provide the students high performing student models, but those models are really requiring students who need to consider about that. And beside, we also have the model accuracy and transparency that I have previously explained. Some models may have the higher accuracy, but the low transparency. Some models has the low transparency, but have higher accuracy. So those are the things that we need to consider. As a conclusions, and then the concept of personalized learning is not new. So we can trace back to the great philosopher like Confucius and Socrates. And then right now, based on with the advantage help of the technology, we can provide a one-to-one teaching on the mass scale. So of course, computers is an essential and will be inevitable in the future educations as well. So these are the interesting research problems related to the student modeling and assessment. So how do we have the data-driven cumulative and validation or refinement methods, efficient method? And then how do we have the simple and interpretable models? And then how do we construct the personalized learning path through the efficient learning policy based on the item similarities and item selection methods? Yes, this is the end of my, so our goal is not to replace the teachers, and in the classroom, instead we are giving assisting them. So this is the end of my presentations. I may have the same contents related to the request to the Dr. Yobas later. So should I continue or just
Again, sorry, I
so I
can't
have
hear
the
you.
same content. Sorry, I have the same content related to the request of the
Okay.
you to give the answer automatic short answer grading test. Do you
You
want to
mean?
continue
Oh,
or
yes, yes,
later?
please. Yes, yes,
Okay,
you can continue. Maybe we check with the participant, and if they have any question, any comments
okay,
before we continue.
sure.
Let me check the chat. Okay, greeting. Oh, here we go. Okay. I saw some comment from LA. Good morning. Greeting from Angeles University Foundation. Hi. Good morning. Yes. So good morning again. And are they, let me check with participant again. Do you have any question before we move on to the next portion of presentation? Okay, so far. Okay, so far no. So Dr. Simon, please proceed.
Okay. So in here, I would like to extend about my presentation a bit according to that might be interested by the community, I guess. So in here I have extended some topic to related to the automatic short answer grading tests. In the earlier uh, um, stages of dealing with this problem, we use the rules-based systems and the back of what embedding. Each of these methods have their advantages and their disadvantages. So these are early stage of the research on the automated short answer grading tests. But I might emphasize we give to the automatic grading the usage of the artificial neural network that are more intelligent and more performing. So in where we use like the recurrent neural network and LSTM, and we also use the transformer models like BERT or GPT. That's a generative pre-trained transformer. So we use in here recurrent neural network, we need the label data to make the automated to grade the responses. But the transformer models, like, they take the deep contextual information from the responses, and then they can do the gradient based on the based on the specific grading text in the B embarked, and for GPT, it can provide the human-like response for the comparison. So let me give you an example with ChatGPT. If you ask the ChatGPT to grade about the question and answer, and then you wait around with the criteria that you want to measure. So the ChatGPT can provide the response like this. So this is one of the things you can then, but I don't really recommend to use this because there's a lot of problems still right now. Large language models are really effective, but we still need some future investigations whether it is usable directly usable for the doing the grading tests. Because these are the challenge facing from two perspectives. So these are from AI perspective, there might be a bias. So the large elements that is data driven and use a lot of data, and then if the data there is a bias in the training data, it might lead to the unfair gradings. Like ChatGPT may be more likely to give the higher grades to the student who write in the site with the family. So besides, we have the interpretability issue. So even we give the grading criteria to the model, we can give the grading, but how do they grade on the more complex and more complex question and more complex responses? We are not clearly known about why the system would grade like this. And then we have the problem of generalizations. We are not unsure about the model generalized across all different topics or all style of writings. This is also a very challenging point. Now, for the student perspective, so some students may not track the algorithm if you see the error, something error in the grading system before. Even right now algorithms are performing better than the humans. Sometimes it may have the peer influence. If the student had some complaints from their peers, they might think, okay, there's problems in the effectiveness or the fairness of the system. So auto grading and natural language process is an evolving field. And then there's continuously evolving and new models and the techniques are developed. But I don't really suggest to use this immediate use of this right now. So it is there's a lot of measurement we need to do before the predicate usage. And then so if you are users, I would suggest to train your own models and use it use it with your own training data and then test it before using it.
Dr. Simon? Dr.
Yes.
Simon, can I interrupt you with a question?
Yeah, sure.
Yeah, I think you mentioned about the user of the ChatGPT to do assessment, which is do not recommend, and to
I
train the
do not
model.
recommend.
Yeah, actually I agree. But then training our own model, I think that's quite challenging, right? So,
Yes.
so I'd like to ask you if there is any way or any software or any company to work with us, to work with the the healthcare educator to kind of build the model which is transparent and also safe in terms of data, secure the data. You have any recommendation on that, please?
To be honest, I don't know. To your questions, I don't know
So
the
it's
answer for your
still
question.
under the development, is it? It's
So
not.
yeah, it is not the thing that we can do day and night. So we need to have a lot of research and we need to a lot of testing to before but it may exist, but I don't really know about if you ask me to recommend which one is more safer and which one is more reliable. Yeah.
Okay, so that's fine. Thank you. So at least the recommendation is not to use ChatGPT to mark the
AI so
assignments.
far,
Okay.
yeah.
Okay. Thank you. Okay.
Yeah, because beside on that, I would like to extend a bit on the AI perspective in a hacker educator. These are some points that I would like to mention is because AI, the performance is really depends on the quality of data because AI, today's AI tools are data driven. If it really depends on the quality and quantity of the training data. If we throw the garbage in, the output will be garbage, right? So besides that, we have the bias issues. So if the bias exists, so the output of the AI tool will be biased, something like it will provide the skewed perspective or incomplete understanding of the certain issues. And besides, we also care about the AI hallucinations. Some of the risks of AI generate the false or fabricated informations. So not all the responses from the AI is accurate, that we need to know about that, and then which can lead to the mislead the educator, in particular in the medical context. So that might be the problematic if it's concerned with the critical medical concern. So besides that, it's
Okay,
lack of human
Dr. Simon,
insight.
Dr. Simon,
Yes.
yes, sorry to interrupt you again. I found one question which is kind of linked with with this slide. So the question is linked to the AI hallucinations, right? So then the question is from the participant, how can we minimize hallucinations?
That's a good question. So let me
Any
give you
thoughts?
a bit more example about the AI hallucination. So
Okay.
in here, that is the study done in the 2023. So in here, the Carlos and his colleagues used the ChatGPT to answer the medical related questions. In that study, they only discover only half of the 65 questions that ChatGPT can answer correctly. And 23% they have the partially or impartially partially corrected or incomplete responses, and the 93% that is to the really irrelevant response, and then 60.9% that is really mislead or entirely incomplete, that we call AI hallucination. But you see the ChatGPT model. In a ChatGPT model 1, we have the 1.17 billion parameter. In the 2, 1.5 billion parameter, 1.75 billion parameter. But in the ChatGPT 4, the OpenAI didn't disclose how many parameters had existed in the model, but there a lot of some researchers estimated 1.3 million parameter, but they did not disclose which training data they have used in that in the ChatGPT. So the question is, it really depends on the quality of the training data and the content of the content of the training data. So we need to, before throwing into the AI models, we need to be very careful analysis of the training data and then uses for the training. But yes, because if OpenAI didn't disclose what kind of data they use and how many parameters they have, so that kind of big problems, right? So this is the to honest, I don't know exactly how to mitigate unless you train
Right.
your own models. Yeah.
But you
Yeah,
see,
besides.
this ChatGPT, they actually invested a lot of money, right, on that. And
Yeah,
then,
indeed.
okay. All right, please proceed. Thank you.
Yeah, so for because hacker educations, when we talk about hacker is dealing with the human, right? So the AI so far AI doesn't have feeling yet, and they suffer. So we do not, so AI don't know documentation, empathy, or perfectional judgment. So it lacked of human insight. So besides, we also related over reliance on the data. So AI-driven tools are mostly data-driven. So if the wrong data is in and the garbage way out, so even with the right data, once the data is the model is quite complex, something like that we are dealing with the whatever technology, other sensor data, they have a lot of features or something that then throw into the systems, and the model is quite complex. It might produce the inaccurate or difficult responses by the outcome by the AI models. Besides, we also need the human supervisions. It's the same for the software development as well. During the phase of the development, after the development, so every time we require the human supervisions, especially in the AI and hacker educations. So it should be a kind of supplement, not a replacement for the educator. So because education is shaping the futures of our generation, so if you are gonna let the machine to shape the futures of our generation, that is a kind of consideration. So that is the end of my presentations, and in generally AI in many ways stay in infancy. It's beginning state, and then there's but that is developing very fast. Yes. This is the end of my presentation. Is there any, I will welcome to any questions.
Yeah, okay, let's see. Are there any questions from the participant? Okay, here we go. I got one question from Raj, one participant. He said, hi, wanted to get your opinion on whether AI tools such as ChatGPT are limiting the critical thinking ability of students. Thank you.
It depends on the people who use it, right? So if some of the if the person that's use is for getting the informations and constructing their knowledge, and then they might be the ChatGPT may be the source to give the more information than the previous Google search like that. But if the person doesn't want to think, okay, just take the response from the ChatGPTs, and who want to give the response to the it depends on the personality of the people. Yes, for me, it may be giving the chance to the person who are lazy to make the critical thinking, probably. Yeah, this is my opinion.
I see. I think so. I think he mean the using the ChatGPT for the student when they're producing assignment. Am I correct? That's what the question asked. Yeah. So
Sorry.
yeah.
For
Right.
the assignment, if the student use
if they use ChatGPT to like produce
without
to
thinking,
write.
yeah.
How is the any policy in Canada, in Montreal, like regarding the use of ChatGPT in producing assignment and submitted to the class, to the of the course? Any policy from there?
No, actually, it depends on the institutions, because some institutions they don't allow to use it, but actually they don't really have the control over that.
Yeah.
But yeah.
Right. So they can't stop.
We can
we
stop
can't
using
stop them,
AI.
right? So yeah. So but then I think that's one of the question from the participant that sent in advance. So one of the
Yeah.
question asking like, then are there any software or any program that you can like detect whether or not they're using the AI to or ChatGPT to produce assignments? Are there any way to do that?
No, actually, there's some of the
Mm,
tool that is something like a Grammarly. They can detect the test if whether AI produce or not. But
mm-hmm,
I don't really sure about the percentage and
mm,
the result given by these systems.
mm-hmm,
So I don't for me if you use ChatGPT, that is fine because to be honest, I also use the ChatGPT to smooth the some sentence in the some of the publications.
okay. Mm-hmm.
Yes, but the directly copying the content from the what they have given is a problematic, and then it should not be allowed. And so we need to learn about how to coexist with the AI, especially ChatGPT today's, and then so there's some data maybe good enough or to detect it or may not probably. If after detecting whether the student has the AI content, what we are gonna do it? That's the questions that we
Yeah,
raise.
yeah. Do we consider it's plagiarism? Would there be
Interesting.
any penalty? So it has that's the question, I guess. No.
Yeah.
Right. So I like to add to that since we're talking about how this matter. So in NUS, National University of Singapore, we just have some policy launches in this month, 7 August 2024 this year. So it has a kind of like highlight the issue regarding the use of AI in assessment from the faculty member perspective, for the teacher perspective, so and then from the student perspective. So for the faculty member, then we have to be very
So
transparent.
I
We'll
can
be
hear you.
using the
There's a
AI to kind
distraction.
of like assess. Yeah. Oh, can you hear me? Can you hear me? Hello?
Yeah. Right now it's okay.
Okay. Yes. So regarding the NUS AI policy for we have two perspective. So from the faculty member and also student perspective. For the faculty member perspective, we have to be, if we use them, we have to be very transparent. We have to seek permission from the HOD. So must be a formal paper to seek uh, approval from the head of the department before we start using it. So that the policy has been, and among all of those detailed policy. And then for the student using AI to produce assignments. So as a teacher, we're supposed to speak to them. We can't stop them, right? So we have to explain to them that this is concerned the ethical issue. So they probably can use some information to guide the assignment, the direction, but they can't just copy the information. So we have to kind of teach them how to use it ethically, appropriately, if we can't stop.
Yeah, that's true.
Yeah. So that's from policy perspective. Yes. Yes. Yep. So are there any question from the participant? No. Right. Anything to add, Dr. Simon? Otherwise, I have some list of questions to ask you.
Yeah,
Yep.
sure. There's nothing for me. Yeah, you can ask that question.
Yeah. That is quite interesting. Chavon has compiled. Thank you so much, Chavon, for compiling a list of questions to ask Dr. Simon. And let me go to this. So many of those, but I'll pick up the one, some of those. So let's say there's some category here. The first one is about ethical concern. I think we did address that. Okay. Okay, all right. This is the one. Okay, so one question is how to use the AI in assess writing skill.
Mhm.
Are there
Yes,
any
yes,
software?
that I was mentioning in the automated grading task. So uh, how do we make the assessment? Usually, these are the two types, general type of models that are more effective. There you can use, but for the IN and LSTM, you need to train, and BRT also you need to train as well. For the GPT that can provide the contextual information explanation by the models, but the rest of the model you need to train your own models.
Right. So this the model that you recommend to
Yeah.
okay. But we need a expert engineer, right, to help us, because from the yes. So from the educator perspective, we might not have access to this model. So would you have any suggestion to get, the software or anything regarding this model? Is it available in the market?
Usually, actually, to be honest, I don't
Yeah.
know about. Yeah, some
Okay.
of the company they might provide this service,
Mm.
but uh so first of all, you need to prepare your training data, and then you have to do the you have to have your label,
I
and
see.
after that you can do the research collaboration with the computer science departments or students from the computer science. They are willing to do that kind of thing, I guess. Actually,
Okay.
we in here we also have the very cross-departmental collaborations. Those are really produce the uh, high output research, and that provide improving the school how to say school systems to improve from those researches.
I see. Okay, thank you for that. Let me, okay, quite a few. I think it's quite, question are quite similar. So I'll pick maybe this one. I think you mentioned about that in the lecture or in the presentation already, but maybe emphasize one more time. So it's about ethical dilemma and using the AI. Would you like to highlight again?
Yes, it was. I was already mentioned previously
Yeah,
here. So
yeah,
these are
yeah.
the
I saw.
main
Yep. Right. I like
I
to.
think
Yep. Yep.
usage of the AI in the dilemma in the AI in education. So yes, data privacy, of course. So with my experiment in the France, so what we do about the experiment, we are very difficult to do the human trial based on even the educations when we want uh to to do the experiment with the real humans, that is to collect the data from the real humans. That is the very strict policy in the all Europe. It's called GDPR, and then so it is quite difficult to collect uh, um, the data because of the privacy issues. So those are really how to say pushing back to the research was what I think that, but yeah, that's life.
Okay. Thank you so much. I would pause one more time to see if there is any question from the participant. So
So
let's.
I
Yep.
see that there's some question that is related to the drawing. Instead of assessment on the language, the assessment over the drawing structure of the molecule. So it is totally possible, and then by using computer visions and then structure the difference between the two structures, and then we can do the assessments whether the percentage of the similarities and the differences, and see, and then we can do the assessment over the drawing. Yeah.
I see. I see. Yeah, I'm quite. Yeah, for I think probably been is a question from me. In your presentation, you talk about the formative assessment. I think there's a
Yeah.
probably a possibility to use, you know, for the class, for to assess the student knowledge, and it's come up kind of like maybe less concern about ethics, you know, so summative assessment. So would you like to give us example, a concrete example of how to do a formative assessment? So yeah,
So this is the
any, yeah.
model that I previously mentioned about
Right,
that this one
yeah.
is to the formative assessments.
You
So
mentioned the
every
the
time the student, it takes the student performance as the inputs and then estimate the student data. That is the kind of assessment, student assessment of the student ability. Based on that ability, the student will be given the items or problem related to that is appropriate to that ability. So there's adaptive learning is a kind of choosing the right items at the right time to suit with the student learning ability.
Yeah. Again, are you aware of any software? Something. Sorry, I'm keeps asking about software for because we probably understand the concept, but then for the application, we need a tool. We need software to kind of guide the
So
implementation. Any
actually, this
software that we can rely on or can refer to?
so so that kind of things is I need to
Okay.
I would like to say this is a kind to integrate to your system. So
Mm.
so I would say it's not quite difficult for computer science student. It's just a couple of lines. Some of the models has a long history. You can see the Big 80 since 1990. So it has a long history and various developments. So you can just directly use there's sometimes you have the code available online, so you can just directly use the code directly and apply it to in your system. That is possible. So you don't really need to buy the software or
Yeah,
something like
I
this.
see.
Just recruit a couple of grad students from the computer science department and then ask them to do that. That is completely possible.
Okay. Yeah, I think that would be all the questions I have, and then I didn't see anything from the participants. So thank you very much, Dr. Simon, for
Thank
give
you.
us the wonderful presentation, and you kind of highlight the basic and solid theoretical backgrounds on the assessment, and that's all the model. That's, you know, it's kind of like enlighten us and give us some idea to kind of like think about, reflect on, and then probably move forward, you know, to the application part. Okay, thank
Yeah.
you very much for your
Thank you for
kindness,
having me.
yeah,
Yeah.
today. Thank you so
Yeah.
much. So if you
Thank you.
stop the sharing the screen, I would like to
Okay.
share something. Yes, thank you so much. And
Okay.
I think we have something else to share the screen before we end today webinar. Okay, so please, yes. So thank you for all participants, you know, for joining me and then, you know, be with us on the journey of the AI development in healthcare education. I think we still, again, in the early stage, and if we work together, I think we probably achieve the goal, you know, to provide ethical and solid assessment or the application of AI in education. So here's the another webinar would be coming in 11 September. So after we learn background from Dr. Simon, then we move on to another AI assisted assessment system from Dr. Neil McNulty. So he was talk also more about, again, about the assessment and application. And here we have another webinar coming up in October is regarding the AI application ChatGPT and ethical consideration. That's one we think we have a lot of time to talk more about ethics. And then December, we talk about AI driven mental health education. Okay, and November is still in process. All right, so let's move on to the next slide. So please, I asked you to really provide us some feedback. So you might scan this um, QR code and provide us some feedback and tell us what to do, in the next step, so we can continue to provide some information. And also, another QR code on the right side is about our website and social media. So if you scan into there, you can visit our website, which we have our record from the previous webinar and information about our NUSAI health community. And also we have the Instagram and our YouTube channel. So please join us, and you feel free to access our website. And again, thank you, Dr. Simon, for your wonderful presentation. And thank you, Chavon. Is she there? She's, yeah, thank you for organizing. You're such a big help for organizing this webinar. And thank you, all participants. See you again in September. Okay, bye-bye,
Thank
and
you.
have
Thank
a
you very much.
wonderful day.
Thank you for
Bye-bye.
having me.
Bye-bye.
Bye
Thank you
bye.
so much.